Hey guys, what's up? I'm Trockers. Welcome back. Today we are diving deeper into connected particles on rough inclined planes. If you want to succeed in this topic, there are a few key things you must always do. The first one, you have to draw clear freeboard diagrams. Secondly, you need to state the direction of motion. This is very important. Thirdly, you must apply the Newton's second law of motion on each particle separately. Then finally, you need to always remember that friction opposes the motion. It's not always down the plane. It depends with the direction. Right. So we have a ZIMSEC November 2015 paper 2 question. It reads, a block P of mass 2 kgs lies on a rough plane inclined at 30 degrees to the horizontal. It is connected to a block Q of mass 3 kgs by a light inextensible string passing over a smooth pulley. The blocks are released and Q moves vertically downwards. The coefficient of friction between the block P and the plane is 1 over 5. A. Find the acceleration of the system. B. Calculate the tension in the string. Right. So this is just an annotation that I need to make here. Remember, we are supposed to draw the free body diagrams separately. So I need a free body diagram at P and of Q as well. Then we need to state the direction of motion. But here, since Q moves vertically downwards, it means P is moving up the plane. Right. Then what else? Okay, so we need to find the acceleration as well as the tension. So you're going to see that tension in the string here is the same. Why is it the same? It's because we are told that the smooth, or it's passing over a smooth pulley, so there's no friction on the pulley, hence the tension is equal. And also for motion, so as soon as this one is, as soon as Q is released here, right, it moves down. But while this is moving, P begins to move at the same time, and they are moving with the same acceleration. This is because of a light inextensible string, meaning to say it does not stretch. So guys, let's go ahead and get started. All right, so I'll start by drawing this. Okay, I need this diagram up here. All right. We have our pulley there. Okay. So this is Q. All right. We have okay, it rests here, and we have P there. Right. So remember, here we can start by, even before we draw the free body diagrams, we can state the direction of motion. So here, that's A. These are meters per square second, and here it's going down, right? It's what meters A, meters per square second, right? Uh, Even if they didn't tell us that Q moves vertically downwards, you need to consider the weight of each, the mass of each particle. So as you can see, P, yeah, P weighs 2 kilograms and Q weighs 3 kilograms. So 3 is more than 2, hence Q is going down. So once Q moves down, it means P is moving up. Okay, then so now we need to apply the forces which are acting on each and every particle here, right? So we can start with Q. So with Q, so we have okay, let me use red here. All right, so this is the weight here. So weight is always equal to our mass times acceleration due to gravity. So our mass there for Q, I think the mass is 3. So this is going to be 3G newtons, right? Then we have our tension here. So we have our tension, and here the tension, you don't need to differentiate the tensions like labeling them tension 1 and tension 2, because this is the same tension because of the because of the smooth pulley there. Right. Then what else do we need? So we are done with the first one here, right? Then now let's move on to this one here. So always remember we have the weight, right? Started at the center here. So weight is always acting. So here it's always acting vertically downwards, right? So since this was 2 kgs, so our weight there is going to be 2g newtons as well, right? Then because of because it's a rough inclined plane, there's going to be friction, and remember, friction acts in the opposite direction, so it's going to be mu r, right? Then what else do we need? So our reaction force here, right? We can call it R, right? So our reaction, which is the normal force there, is our R, right? So we are going to resolve this weight here into 2 components. Firstly, we'll resolve it perpendicular to the plane, which is into the plane, then parallel to the plane, which is down the plane, right? So here I'll put a dotted line, right? So when I do that, it's going to be, so this angle, which is 30 degrees here, right, is the same angle there, right? Maybe I can quickly explain why I'm saying that angle is the same. So if we look at this, like we have a right triangle, something of that sort. We have this triangle here, right? So when we have our triangle, right, this is what? This is say this is 30 degrees, right? Obviously that's our 90. Then we have this part here, right, which is acting vertically downwards, right? So when it's acting like that, right? Okay, so we have this, we have our if we resolve this into that, it's going to give us that part. So as you can see, this is now 90 degrees, right? But we had, so 30, 90 here, this was 60, and this becomes what? That becomes 30 as well. So, okay. So always that is what? Always that is 30. This is 30. So this angle is always equal to that angle. And as you can see, right, this angle here, this is 30 degrees, right? And if we have, okay, so suppose if I do this, that's a little bit of 90, right? Then this is 60. Then since this is now a right angle, so 60 plus that will get what? We'll get 90 degrees. Okay, so that's 30. All right, so let's not dwell much on that. Then if we resolve here, right, so it's going to be, so that's going to be opposite. So here it's going to be mg cosine of theta. Our theta is 30, right? But our m is what? Our m there is, sorry, our m is 2, so it's going to be 2g, right? 2g cos theta. Then if we resolve parallel to the plane or down the plane, we have this, so this part again, so it's going to be mg, which is 2g sine 30 here, right? So we have those, I think we are done. We have applied all the forces, right? So now remember, the other step is to apply the Newton's second law of motion, which is F equal to mass times acceleration, right? So now our M here, so if we consider this motion, right, our force, since it's going down, is going to be 3G, minus tension, right, is equal to 3A. So that's our first, right? Then we have this one here, the second one. Since we are moving up, so it's going to be tension subtracting this one is reaction. So coefficient of mu is the coefficient of friction, which is 1 over 5. So it's going to be 1 over 5 of R. So reaction, so from here, guys, R is equal to 2G cos 30, right? Which is R equal to 2G cos 30 is root 3 over 2. So our R is root 3 over G. So it's going to be R, so root 3 over 5, right? Then G, because mu R is root 3 over 5, G there. Then our mu is 1 over 5. Then we also have another force here. So if I say 2G sine 30 is 1/2. So it is just G. So minus G should equal to, then that's 2A. Right. So we have to solve these two simultaneously, these two equations involving T and A. So we have to solve them simultaneously. So if we are to leave our answers in exact form, we don't, we just leave them in terms of G. Otherwise, we are going to use 9.81. Okay. So first, we need to find the acceleration. So we have to eliminate G here. Okay. So I mean we have to eliminate T. Okay. So in order for us to eliminate T, what we need to do is just to say, okay, so T from equation 1. All right. Okay. So from 1, T equal to 3G minus 3A, right? That's the third. So we apply third into second. So it's going to be 3G minus 3A minus root 3 over 5G minus G equal to 2A, right? So if I consider this and that, so it's going to be 2G minus root 3 over 5G equal to 5A, right? This and that, I think it's going to be, okay, 5 times 2, so it's going to be 10 minus root 3, right, over 5G equal to 5A, right, which is equal to, so A is equal to 10 minus root 3 over 25G, right? I need the calculator here. Okay, so you could either leave it like that, or we can apply, we can calculate, this is 210 minus square root of 3, okay, over 25 times 9.81. All right. Okay, so which is, therefore, A is equal to 3.244 meters per square second. So that's our acceleration here. So now that we have the acceleration, we now have to move on to part B of the question, where we need to calculate the tension in the string. Remember, the tension is uniform here. So on part B, to find the tension, we just need this equation, T equal to 3G minus 3A. So T equal to 3G minus 3A, which is 3G minus 3. Then for A, let's use 10 minus square root of 3 over 25G. Right. So first we need to write the exact value, right? So it's gonna be 25 times 3, that's 75. So that's 75G. Then if I distribute this minus 30, if I distribute that plus 3 root 3, right, G all over 25. So it's going to be 75 minus 30 should be 45, right? So it's 45, 45. So it's going to be 45 plus 3 square root of 3G over 25, right? So this one here, need a square second, right? So you can either leave it like this, or let's find the so for the tension, is not, the tension should be in newtons, right? Okay, so here it's going to be what? If I say 45 plus 3 square root of 3 over 25 times 9.81. All right, or 19.6 696, so 19.697 newtons, right? But remember, guys, if the degree of accuracy is not specified, and if the answer is not exact, try to leave your answer to two significant figures. So it's going to be 20 newtons to two significant figures, and this one here, it will be something like 3.2 meters per square second. Otherwise, just leave your answers in exact form. So that's all about connected particles on rough inclined planes. But remember, guys, if you need to succeed, you must always do these things. One, draw a free body, draw clear free body diagrams. Two, you need to state the direction of motion. Three, you need to apply the Newton laws, the Newton's second law of motion on each particle separately. And always, friction opposes motion. It's not, it doesn't mean it's going, it's always down the plane. It depends with the information given. So with that being said, guys, I will see you in my next video. Take care.